I want to focus on logs. It's a big area to cover, so you need to pick something to stick with. So what is ClickHouse? How many of you have heard of ClickHouse before? Oh, wow, that's far more than I expected. Cool. We're getting popular. So ClickHouse, it's a OLAP database. The development of it started back at Yandex in 2009. It actually, I was in ads and ClickHouse. I was in Ads Engine, and ClickHouse was started around the Ads Engine for the use case of Yandex Metrica, which is Google Analytics competitor in the Eastern European market. And I worked very closely with the ClickHouse team from the very beginning. And ironically, I joined ClickHouse now. It's very far from Eastern Europe and much bigger company, much bigger thing. So it was open source. The development of it started in 2009. It was open source in 2016, and being in the wild since then. It's a column-oriented database. Because of that, provides great compression levels. It's based on LSM trees. That's important for our use case or for our discussion today. Because of that, it's good for ingesting lots and lots of data. Actually, ClickHouse works best when you batch the inserts to it, and works worst when you issue single row updates, single row inserts. It's not really the mode it's meant to operate in. And it's fast, as you might know. People who know ClickHouse know that it's fast. It has plenty of small optimizations that makes it just crazy fast compared to other column data stores. So is ClickHouse a good database for observability? Well, some observability companies choose ClickHouse as their backing data store. That would be Runcover, Signos, Deepflow, CoRoot, HyperDX, CloudMate, OneUptime. It's probably okay. Lots of new, fresh startups that are working in the observability space chose it. But these companies' business is observability. They have a lot of people working on it. And what if you want to build your own? What if you want to build your own, maybe smaller solution, or you want to try, I don't know, building a new business out of it? Smaller scale with limited resources. Can you do that? How far you can get with using just open source, which is ClickHouse, part of open source, today? Let's talk about it. Let's see what it's going to take today, this moment, to build an observability solution with open source based on ClickHouse. It's a lot of ground to cover, as I mentioned. So for simplicity, let's just focus on the logs use case. Or logs. It's cool. Let's start with a simple setup. We have a single service called my service. I don't know, good name. It writes it's structured logs in JSON. It's a really good service, very well written, structured logs, I respect, to this directory or log my service, and you know all the JSONs there. See what we can do here. To build an observability platform, we need to solve at least 3 problems. We need to solve the problem of collection of telemetry, storing and querying it, and visualization, because why would you need to collect telemetry if you cannot look at it and make any sense out of it, right? So let's see what we can do with the open source. Let's pick some cool open source. For collection, let's use OpenTelemetry. For collection, ingestion, and enrichment, let's use OpenTelemetry. For storage, obviously, let's use ClickHouse, of course. For visualization, let's stick with Grafana. Let's stick to the classics for this case, but really you can use other modern tools that have very good integration with ClickHouse, that are less classy, like Signals, for instance. But let's stick with Grafana for the discussion. Let's start with collection. OpenTelemetry. So open source did its magic in this data collection setup. Where projects like OpenTelemetry, or OTel for short, they were created by a community to address specifically the observability or telemetry collection problem. OpenTelemetry is a CNCF incubating project. It provides a set of vendor-neutral APIs. It's an attempt to standardize the observability. So it provides vendor-neutral APIs, SDKs, tools for instrumenting your code, generating telemetry, collecting telemetry, enriching telemetry, everything that you need for the collection step. It supports traces, metrics, logs, dumps. It has primitives for all of that. With different level of support for each one of this telemetry signals, but good enough at this moment. So, for instance, the log support was GA in OpenTelemetry in November 2023, if I'm not mistaken. And well, we'll see what you can do with it right now. OTel is slowly but surely establishing itself as an industry standard, and this standardization makes it significantly easier to integrate with different storage layers, front ends, and break free from the vendor locked environments. Now, let's talk a little bit about OTel collector. The thing that on this diagram is right in the middle, the main component of it. So OTel collector pipeline consists of receivers, processors, and exporters. Receivers are all about how the OTel collector gets data. Good example of a receiver could be a Prometheus scraper. Or, as we're gonna look at later today, could be like a tailor, like a log tailor. Now, it also can take the input from a different OTel collector. You can chain them. Processor, it applies different transformations or calculations or aggregations or data enrichment to your data. You can, like often it's used to add additional attributes to your data. Let's say there's a Cadis resource, a Cadis attributes of a processor that you can configure that is gonna enrich the log messages that are coming from a particular source with a set of tags and labels that it can collect from your Kubernetes instance. Now, the last step is exporters. So exporters demand to send data somewhere. It could be stored, it could be processed, it could be shipped somewhere to another OTel collector, to the backend data store. The goal of an exporter is to get rid of this data from this particular OTel collector instance. So let's take a look at the list of available receivers in the OTel contrib repository. It's a lot to pick from, right? We're building a logging use case. We're building the logging solution. So for our simple use case, we just need to tail logs. Here we go. There is a file log receiver. It does exactly that. We point it to the log, we tailed it, and it's farther to the pipeline. What about exporters? We chose ClickHouse. We chose ClickHouse for our observability platform. I like the word. Is it supported? Is it there? Yes, it is supported. Now, we skip processors, but really, in this case, for a very simple use case, we using ClickHouse as a backend data store, we only need one processor. It's necessary, batch processor. And that is because ClickHouse is based on LSM trees. And we don't want to ship every single line of code, every single line of logs that we're scraping to the ClickHouse individually. We want to batch. That is this is essential for a good performance if you're working with a ClickHouse. It's basically rule number one, batch. So if you want, something to change to do a different behavior, you can chain the processors. We're directly one processor to another processor. And that's actually important because in OpenTelemetry, the order matters. So if you will be trying it on your own and it doesn't work, try to change the order. All right, so again, the simplified view of like a generic auto collector pipeline. We need to define receiver, we need to define processor, we need to define exporter, or receivers, processors, and exporters. And that's what we came up with, right? For the receiver, we're using file log receiver, which is handling the logs. For as a processor, we use batch processing because we want to batch the data before shipping it to the ClickHouse. And we use ClickHouse exporter to finally deliver this data to the ClickHouse instance. Let's see how we can configure it. OTel, auto collector, has many of modern software, takes YAML as a config. So here's a chunk of this config. Basically, we just define that we're going to be using file log receiver, and then we configure what type of it is a JSON parser because our service is good, logs are structured already. We need to extract the timestamp because, well, it comes in a different formats, and you need to specify what format it should be looking for. But basically, that's it. It's a very simple config. And that right corner, you see, I'll get back to it a little bit later. What's that? But it's basically our pipeline in the validator. Now, processor is super simple. We only use batch processor. Batch processor has some configuration options, but essentially we care about two: time-based batching and size-based batching. In this config, it's gonna send the batch to the exporter when the batch reaches 100,000 lines or records, or when 5 seconds has elapsed. Now the exporter itself, the ClickHouse exporter. There's a little bit more configuration options here, and there's not all of them. But the essential ones is the endpoints. The ClickHouse exporter supports native ClickHouse protocol, supports TCP endpoint, and supports HTTP endpoint. Now you specify the database, you specify the username, password there, the TTL for your tables, for the vectors in your table, and some config options like timeouts, retries, on the inserts, and stuff like that. Then the last part of the config is the pipeline definition. You actually take all of these entities that we've just configured and build a pipeline out of it. So as you can see, it's a list. Receivers is a list, processors list, exporters is a list. You can specify multiple there. And in processors, the order matters. So you will have multiple processors. So there is a cool service that's called AutoBIM.io to validate the OpenTelemetry configs. Ironically, it was built by ex-ClickHouse engineer that left ClickHouse about a year ago. And nobody knew where he's going. Their startup was in the dark mode. It's -0 and they build AutoBIM. So it helps to validate the configs against different OpenTelemetry builds. It helps to visualize it. So if you will be ever writing the OpenTelemetry collector configs, this is your go-to. It's really cool. Basically, here you can see the full config that we just went over and the visualization of this pipeline. We have a file log that sends that to the patcher, that sends that to the ClickHouse. All right, so what about storage? We're done with collector part. Well, it's easy. Let's just use ClickHouse. Obviously. You can pick with between self-managed version and fully managed cloud version. Cloud version has plenty of benefits. The biggest one being that you won't have to manage it yourself. It can get tedious sometimes when your cluster grows. You won't have to worry about the storage capacity. That's the other thing. The ClickHouse cloud architecture is built on with shared everything in mind. And we use it's backed by the object store. Use the object stores to store the actual data. So it scales well. It's virtually infinite storage. It's reliable, and again, you don't have to manage it yourself. But for our use case, for this small service and small platform that we're building, self-managed version would be more than. All right. The last part in our platform is visualization. We pick Grafana. So how good it is for ClickHouse? It's actually pretty good. Grafana has official ClickHouse data source plugin, and it's maintained by our team, the ClickHouse's team, and we try to take good care of it. It supports all the telemetry types from Melt. It supports metrics, it supports events, logs, traces. It has whatever Grafana supports, our plugin supports it as well. So let's see some examples of what it's capable of. Well, this is just the dashboard that's backed by ClickHouse data store and with different types of graphs. That's for metrics. For traces, there's an animation here. This is the sample OTel application that OpenTelemetry ships, so you can check how metrics are being emitted, how traces are being collected by your system and by your pipeline. ClickHouse plugin fully supports whatever you need from traces. Whatever Grafana traces pane is capable of, it can do with the ClickHouse's next. And on the log side, this is a screenshot from our internal login system called Loghouse. I'll get back to it a little bit later, showing logs pane is supported as well. It's all that. So we have all the pieces together. Now, that's what our platform is going to look like. So we have my service writing logs into our log my service. Then it's being sprayed by auto collector, exported to the ClickHouse, and we have Grafana for the visualization. Very simple. Let's talk a little bit about the setup and what it's capable of. So it would take ClickHouse instance with 32 CPUs and a little bit of RAM, 128 gigabytes of RAM. It can handle about 20 terabytes or 20 billion log events per day. The data is semi-structured in OTel schema. Semi-structured means that there is a set of fields that are being stored in separate columns. But there's also like a big map of all the attributes and labels that you can use when looking up some specific moment when filtering. And the compression ratios that we've seen, it really depends on your data. But we've seen the 7x to 14x compression rates. That means that 20 terabytes of data, of raw data ingested, of raw logs ingested, they're going to use 2.8 to 1.4 to 2.8 terabytes on this. The setup scales well, both horizontally and vertically. Let's talk about it. So how big we can get? It might work for small service, but how does it scale? How far we can push the open source? So far, it was pretty much well, not pretty much, but zero any proprietary software setup. So how we can push it? How far we can push it? Well, let's talk a little bit about our internal logging platform that we built for our engineering needs inside the company. We have a blog post. I linked it. I'm not sure how to pass it to you, but I guess I can share the slides later. But if you look up how we built a 19 petabytes logging platform with ClickHouse, this is one of the blog posts in our blog. We like to dog food. We built it on ClickHouse, so there's a backend data store. So we started from this trivial setup, right? Like we picked our components exactly the way how we just went over it, and then we started to scale it up. So we have multiple nodes in a single region that we want to collect, that run multiple applications on each node, and we want to collect all the logs from them and store them in the ClickHouse so we can have like a regional view, right? So we can see trends, insights into how our services perform. In this case, OpenTelemetry agent becomes bottleneck because there's multiple applications, and if we're going to start batching on the OpenTelemetry agent side, it's going to consume resources that we need to run our applications. So in this case, OpenTelemetry suggests adding an additional aggregation layer. It's called OpenTelemetry Gateway. It's essentially the same OpenTelemetry agent that just takes the input from other OpenTelemetry agents rather than running a receiver specifically for collecting some kind of telemetry specifically. So what OpenTelemetry Gateway does, it receives the data from other OpenTelemetry agents, batches it, and ships it to the local regional ClickHouse. And then we scale it up again because we have multiple regions. So now we run on infrastructure in multiple regions, and we don't want to transfer huge amount of raw unprocessed data across the regions because it's pricey. And well, let's be fair, this telemetry and these logs are only needed when incidents happen, most of the time. Some companies may use it in a different way, but in our company, we rely on them to investigate incidents and recover from them. So we have very, very, very detailed logs, trace level logs for our ClickHouse instance that we run inside. And ClickHouse is very chatty. If you Google why ClickHouse writes so much logs, you'll see some advice on how to make ClickHouse less chat, ClickHouse server less chat. So what we did is we set up the single region setup. In each of the regions that we run, we collect and process and store the data locally, and we only send data across region at the moment of the query. And we don't send raw data. We don't have like an aggregation of big ClickHouse, which was initially our a naive idea of the implementation. ClickHouse supports storage engine, so-called distributed table engine, which was built specifically for this use case. However, it does send some raw data across the regions. While if we're have a we query directly from the phone interface or from directly from the ClickHouse client or some other application, we're only going to send the data that is directly related to the query result. So it scales pretty well. We have about 40 regions that we run this in, and it's it has a very good isolation, so that there's really no horizontal scalability. So some numbers about our internal login system, how far we pushed it. So we have about 24 petabytes of raw data ingested in it. That is speaking of how chatty ClickHouse server is. We store 6 months worth of data. Our retention is 6 months. And it's 24 petabytes. That's a lot. Now the compression ratio, because we did some improvements to the schema on the ClickHouse side, you can read about it in our blog. I just don't want to go too much into technical details now. The more you denormalize the schema in ClickHouse's case, the better your compression is. Because each column is stored as basically a separate file where you can fine tune and pick the codec very specific for this particular data type. And that makes it very efficient. So we were able to push the compression rate to 17 times, and on the disk is 24 petabytes of raw data. Only take 1.4. Lots of rows, 45.5 trillion rows, and the average size of the log message is about 600 bytes. Now, how fast it is. As I mentioned, we rely on logs in incident investigations. So we don't expect real-time performance. So we were not really optimizing for it in this case. However, with ClickHouse, it's possible. You just need to structure your data in some specific way, build a good schema, and know your patterns. But ClickHouse is more than it's more than possible than to do it with ClickHouse. So average is 1.23 seconds for overall the queries. The P99 is about 5 seconds. There's always outliers, so maximum does not make sense to those, but P99 is about 5 seconds. The median is pretty fast. Those are just like point lookups, okay, how my pod is doing, how my instance is doing, which is very fast in case of ClickHouse. They take like 500, 600 seconds. Now, is it reliable? And that's where we can work on some improvements. That's where we're working on some improvements. Once data is ingested into ClickHouse, it's safe. But on the ingestion pipeline, the ingestion pipeline itself, the OpenTelemetry, can drop it under some circumstances. like the auto collector under some memory pressure, the don't kill. And that was the auto collector that was doing the batching that uses the batch processor. It's a known issue with OpenTelemetry that it's just going to drop that. The common advice in the OpenTelemetry community: do not use batch processor, but we cannot not use it because we need batching for ClickHouse to perform its best. However, the numbers are relatively low. I would definitely prefer them to be lower. And this is what this is one of the challenges that we're looking into resolve, because surprise, we are maintainers of the ClickHouse exporter in OpenTelemetry, and this is something that we're going to improve. All right, so coming back to our question, how far can you get with just the open source today? I would say pretty far, right? You can build like a 25 petabytes data store. Will take you some operational overload to run the cluster this big, but you know, for smaller scale, you can build it. You can build like a working solution. I touched the logs today, but ClickHouse exporter supports, as I mentioned, all of the main telemetry signals. It supports traces, it supports logs, it supports metrics. So it's possible. But there are challenges. Of course, there are challenges. I mentioned one of them, but there are also others. So what are the trade-offs? Well, the first, and from my perspective, one of the biggest trade-offs that you have to accept is that SQL becomes the main query language. ClickHouse does not support PromQL, it does not support LogQL, does not support TraceQL. The native language for ClickHouse is PromQL. There are some not so open source projects like Quira, which introduce this layer of like transpiling from PromQL to the native hotel schema. But the license is pretty strict, and probably for personal usage, it is possible to use them, but it's strictly with building something on top of it. Now, OpenTelemetry in general, is great for collecting traces, great for collecting logs. Metrics can be somewhat challenging, and that's, you know, there's no problem in collecting the metrics. There's a problem with querying them, because, you know, when you work with metrics, you think PromQL, right? You don't really necessarily want to write the SQL query. PromQL covers majority of the use cases of what you're looking to do with metrics. It's a standard. This case, it's not the case. But there are good news. We're working on the PromQL support. It's here. It's native PromQL support, and we'll see what's going to be next. But it's still news. Coming back to the last challenge is that when using the batch processor, you can lose some data. Most likely, small amount, because it flushes pretty often. But, you know, for the observability system, you want to be sure that you will get this telemetry in a vast majority of cases. Because otherwise, why collect it in the first place? And that's all. Thank you. Happy to answer questions. Do you have any?
Do you go like more in depth with the LSM trees and like why you need to do the batch, like in uploads instead of like storage system?
Yeah, I can. I'm not a core engineer, but I can talk about that a little bit. So basically, all the data that you store in ClickHouse, and it's based on LSM trees, but it's not directly the implementation of the structured messaging trees. The family of the storage engines is called merge tree. Basically, the idea is that everything that is stored is sorted based on the primary key. Primary key is the sort key in the system, or like the sort key is the primary key in the system. So what it means that when you insert one row, you need to resort the whole part, like the whole block, data block that is stored. This and then merge it with bigger parts. Is it expensive? Not really. You need to do it, in the background. You need to keep track of these parts, but it takes pretty much the same time and complexity to insert a bigger chunk of that. So when you're inserting like one row after another, you're just pushing more load towards the parts tracking mechanism, the block tracking mechanism. And ultimately, they have their limits. So while if you push like the bigger blocks, they have less to track. It's going to take at the same time, relatively, to insert them 10,000 records and one record. Hope that answers your question.
Oh yeah, in the last slide, you mentioned that hotel drops the data sometimes. Can you tell me more about how that happens and how you go about resolving it?
Yeah, that I can talk definitely. The problem is that some of the implementation of the OpenTelemetry components, they don't strictly follow the contract that is described in the OpenTelemetry standard. And specifically, the batch processor does not guarantee the batch persistency. It doesn't dump it on disk when it gets it. It just keeps it in memory, and it's transient. If in this moment the OpenTelemetry collector instance is going to be killed by link killer or something, or just crash, you're going to lose this batch. And it's not going to send the signal back when starting up to the processor to retry the batch. There's a big issue on GitHub where one very good developer just goes over, he reviewed all the OpenTelemetry code base and noted that there's some places where this contract is just in the implementation, which is not being followed. So what's our plan? Plan is to implement retries on the processor side. Like if the exporter is gonna, or like, it's happening with batch processing. So if the processor is going to report to the receiver that the batch was not processed, the receiver is going to resend it again. That's one thing. Another thing, persist the batch on disk. It's the obvious thing to do.
I was going to ask, the data values that you mentioned, are there multiple tenants using that instance or that infrastructure, and like how many people, how many clients, how many customers are using that infrastructure? So, or is that just your internal operation?
This is our internal operational platform. Okay. It's not exposed to our customers by any means. Regarding the data locality, as I mentioned, we run in 40 different regions. So we have like clusters of different size based on the size of the region. The data producers are services or applications that run in these clusters. So the bigger the cluster is in terms of load, the more load and the more logs it produces. This is the overall amount of data across all of these clusters that it has.
If those clusters represent customers of yours?
Well, yeah, we're ClickHouse Cloud, so yeah, we run lots of ClickHouse for our customers to manage it for them. So yeah, 99% of the logs that we store in Loghouse are either from the ClickHouse server instance itself or from the keeper, which is the coordination service. It's very chatty. It's very.
With you guys network, is there like a trade-off? Do you guys use TCP UDP for like assurance of like the insanity like reaching the destination, and does that like affect how the house works at all in general?
That's a good question. We prefer to use ClickHouse native protocol, which is TCP based, and at the transport layer. It just provides, it's a binary protocol on top of TCP. It provides it's more feature rich compared to HTTP. Yeah, UDP, we don't use it all.
Yeah, so just to follow up on that, like with interactions with like other services that might have to be standards, like how does that, is there like a trade-off with that, or like meet in the middle? Or does like how does ClickHouse like standards like that?
Can you elaborate a little bit? What services you mean when talking to each other?
So we would use, so we do use ClickHouse like quite a bit. We do have like the layer that does the transfer to ClickHouse, and like the other sort of ClickHouse, their transportation layer might be different. So how do you guys work with their transportation layer, or how does ClickHouse expect to like receive data and it's given?
Okay, I might be missing something, but we have a ClickHouse instance, right? The ClickHouse instance exposes TCP interface, and on this TCP interface, it expects some binary protocol to come in, not HTTP, not other protocol than HTTP, not gRPC, for instance. It's just a binary ClickHouse protocol that is implemented in ClickHouse. The ClickHouse client supports it. So if you're inserting data, using ClickHouse client, or there are multiple clients, it supports it. The fallback for, let's say, in ClickHouse Cloud, we provide multiple ways how our customers can connect to their ClickHouse instance. It really depends on how we configure it. ClickHouse supports HTTP. ClickHouse supports TCP native, TCP non-native, which is, I'm not sure why people need it, but in this particular setup, we use native protocol. Other questions? All right, well, thank you so much. Thanks for having me. I hope it was not super boring, and sorry on me being slow.